So I'm Alan Fern, and I'm an associate professor in computer science. And I'm going to tell you about a project that I'm working on with Sinisa Todorovic, who's another professor here. So one of the things that's going to be in this Internet of Things are cameras. There are going to be millions of cameras around, and cameras are pretty special because the type of data they produce is a lot different than just a GPS location. They produce lots and lots of data, and it's very difficult to interpret using computers. We kind of take for granted the human visual system. It's very easy for us to look around the room and count how many people are sitting behind us. There are not computer vision algorithms that can do this reliably. So there's been a lot of progress recently, but we have a long ways to go. So you can sort of take an analogy. It's just been recently that speech recognition has hit a point where it's actually reliable. Vision's a lot harder than that. So Sinisa and I were interested to look at a domain that would have a lot of the challenges that you would encounter in vision systems in shopping centers and parking lots that involve lots of people doing lots of things. And we decided to focus on sports domains, just partly because it's fun, but they also offer huge challenges. And primarily, we've been focusing on football. And so about 5 years ago, we started the Digital Scout project, and we worked with the OSU football team to get their video. And the ultimate goal is to be able to look at a play with a computer and have the computer understand the play, so to produce some description of the play at the level that an average fan might be able to produce. And that was started as an AI challenge problem, but we've recently started working with a company on these sorts of ideas. So let's show you, we worked for a couple of years just on the OSU data, and we developed a system that could, with some reliability, determine what was happening in a football play. And this is just showing you an example of one of the components where you have to track players, and we display the tracks on an overhead view of the field. And then further analysis would then try to figure out what those tracks are actually doing. This is just showing the offense. So we, as I said, we worked for a couple of years to get to this level just with the OSU data. And then a company, they saw this and they were interested. This company is a web service. They primarily work with high schools, and right now they have 14,000 high school clients. It's a web service where they upload video and they can annotate it, share it with their players and other teams. They wanted us to start looking at the possibility of using computer vision to help with the annotation process and other nice interface options that they might want. So we've been working with them for a couple of years now, and I think we sort of face this cliff of death that we heard about earlier. When you start working with a company with 14,000 clients, it's a very different situation than working with OSU football video shot by a professional cameraman. So what we need to do now is work on scalability and adaptability. So 14,000 high schools, that means every Friday night there's going to be thousands of games worth of video uploaded to their servers, and they need to be able to process that quickly. If we're going to spend 5 minutes per play, they have to pay for that on the cloud, and they're not actually going to be able to afford that. So we have to do this efficiently at a scalable level. The other thing is adaptability. Similar to birds in different environments, these are all football fields, but they're all shot by, they're on different fields. They're shot by different cameramen from different perspectives. And it's actually a very scary prospect having to deal with this diversity of data. And that's really our main concern now. So we're trying to get systems that actually work for wide varieties of data and that are scalable. And those are the key things that we're going to have to deal with in the Internet of Things when it comes to video data.